Hello, a very exciting lesson today on logarithms. We are on 5.02 for Algebra 2, and we're going to solve log and exponential equations today. We worked on solving some exponential equations before by trying to get the same base, but that is not always possible to do that. So sometimes we need to use logs. One thing you want to remember about logs is that exponentials and logs are inverses of each other, meaning that they undo each other. They kind of like a square root undoes a squared term. Those are inverses of each other. So first I want to talk about 3 different scenarios that you could possibly see and what to do when you see those scenarios. So we're just going to make a little table here with our 3 scenarios, and then we'll actually do some examples of each. So scenario number 1 is when your variable, so I'll just call it x for now, when x is in the exponent. So for example, you would have like 3 to the x equals 2. When that happens, or even you might have 5 times 3 to the x equals 2. I'm going to change this, equals 10, so you understand the next step. So first thing you want to do when this happens is you want to isolate. So you want to isolate the base with its exponent. So find your exponent, which is x, so we know it's a variable, and the base of that is what's directly attached to it. So just the 3. So 3 to the x is that base. Really, really important that you get that alone. If the 5 times 3 was in parentheses, then that whole thing's being raised to the x. The exponent touches exactly what it should be, what its base is. So if you have 2 plus 3 raised to the x versus if you have 3 to the x, here the exponent is touching the parenthesis. So whatever's in the parentheses is your base. Here the x is just touching the 3, so that's what's going to be your base. So first thing, and the first step in all 3 of these scenarios is isolate, 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 meaning you would get that 3 to the x by itself. Isolate the base with its exponent. So you would divide both sides here by 5, and then you'd have 3 to the x equals 2. All right, after you isolate, you're going to take the log of both sides, or you're going to use logs, and we'll talk about 2 different ways of doing that. Depending on your personal preference, and then, of course, you'll solve for x. All right, that is the first scenario. Now let's look at the second scenario, which is when x is in the base of an exponential. When x is in the exponent, when x is in the base. Make those a different color so they stand out. All right, so first step again, let me give you an example here. When x is in the base, so if you had like x to the third equals, let me give you one that's maybe not as common for you to see before. So x to the 2/3 equals 5. So here your variable x is in the base. So what you would want to do first is isolate. In this case, it's already isolated. So isolate your base with the exponent, meaning you want to get that x to the 2/3 so that it's all by itself. And then what you're going to do is raise both sides to the reciprocal. And we talked about this a little bit last class as well. And this really applies. I mean, sometimes you're going to want to take the square root, and that's fine. That might be easier for you, or the cube root. But when you have a fraction, something like 2/3, it's going to be easier for you to just raise both sides to the reciprocal, meaning take your exponent, which is 2/3, and let me use black here, 2/3, and take the reciprocal of that, which is 3/2, and then you would raise both sides to the 3/2 power. Okay, and then you would solve from there. All right, and then lastly, scenario number 3 is when you're given a log or ln in the equation. So we haven't talked too much about ln's, but ln's are just a natural logarithm, and all the same properties apply for both logs and natural logarithms. You'll solve them in the same way. The only difference is a log has a base 10, and an ln has a base of e, which remember is a number, approximately 2.718, and you can find it right in your calculator, just like you would pi. So an example here might be if you had y equals, actually let's make it ln of x equals 5. So first thing you're going to do again is isolate the log or ln in this case. So my ln, you're taking the ln of x, but there's nothing being added or subtracted to it, so nothing to isolate in this particular problem. And then you're going to rewrite it in exponential form. Like I said before, logs and exponentials undo each other. They're inverses. So when you have a log or ln, you'd rewrite in exponential form like we did last class. So your base is an e, so you would rewrite that as e raised to the 5th equals x, and then you could type that right into your calculator, e to the 5th. All right, we're going to go through now, and I want to do an example of each type. So first we'll start with an example for number 1. So let's find x for the directions and round to the nearest 100th. All right, so our problem is 3 times 5 to the x equals 90. So first you want to look at your equation and figure out which scenario that you're in. So I see an equation and I see my variable x is in the exponent. So if my variable is in the exponent, I'm in scenario number 1. So now first thing I want to do is isolate my base with its exponent. So I look at my exponent as x, what's attached to that? What is the base of that? And that's going to be your 5. So I want to get 5 to the x by itself to isolate. So to do that, I'm going to divide, I'm going to rewrite this, 5 to the x equals 90. I'm going to divide both sides by 3. So now I have 5 to the x equals 30. So now I've isolated. Step 2, now that my variable is in the exponent, now I can take logs of both sides. So here I'm going to literally just write log in front of each side. So I'm going to write log of 5 to the x equals log of 30. So nothing changed except I wrote log right in front of them. Everything else stayed exactly the same. Now we can use this property of logs, which is my favorite property of logs, which I like to say it's the swoop property. And anytime, once you put the log there, you're allowed to take the exponent and swoop it to the front. So this is really important, and this is one of the main uses of logs, is that it allows us to solve for a variable that's in the exponent. So now I can write x times log of 5 equals log of 30. And to solve for x now, I'm just going to divide both sides by log of 5. And now I'm going to type this into my calculator and get a decimal. So in my calculator, I'm going to take log of 30 and divide it by log of 5. Or you could use your alpha y equals button and do log of 30 here divided by log of 5. Whoops. Oops. I don't know why it's... Okay, so then we get that same decimal. So again, of course, you would write out your entire decimal. And then 1132. And then it said to round to the nearest hundredth. So that would give us our 2.11. Now, before I move on from this one, I do want to show you another way you could do this. So once you get to this point where you isolated, you could also just rewrite it. This way is a little bit faster. Some students prefer this method, and some like to stick with taking the log of each side. So you would rewrite it as a log. So once you saw that you had a variable in the exponent, you'd have to say to yourself, okay, whenever I have an exponential, I'm going to rewrite it as a logarithm. And here is where you really have to know your setup of your logs, which you need to know. So your base of your log is 5, since that's the base of your exponent. And then you've got these two empty spots here. So we want 5 to the x equals 30. You want to rewrite it as an equivalent logarithm. So remember, it goes the base raised to this number over here. So your x will go there. That's your exponent, equals 30. Okay, so when you rewrote that as log base 5 of 30, why that helps you is that now these newer calculators that we have, which wasn't the case a few years ago, now we can go here and go to your alpha window, choice 5, and type in base 5, log base 5 of 30, and we get the exact same answer. And then so then you type it in your calc. And you get your 2.11 again, same answer. So two different ways, again, either is fine. So whatever you are more comfortable with. Next, let's look at an example for number 2. All right, so for this one, again, find x. And round to the nearest, we'll do 100th again. All right, so for this one, the equation is 2 times x to the 4th equals 18. All right, so now, same thing here. We're going to start by isolating. So number 1, isolate. So I want to get the base with its exponent alone. So I need to get this x to the 4th by itself, which means I'm going to divide both sides by 2. So I'll rewrite it here. 2x to the 4th equals 18. Divide both sides by 2, getting my x to the 4th by itself. After I isolate, now I want to raise both, so I want to ask myself, what scenario am I in? And I should be in number 2 because my variable is in the base. The x is in the base of an exponential. So raise both sides sorry, it's getting hard to read, to the reciprocal. All right, so I'm going to rewrite it again. So x to the 4th equals 9. So what I'm going to do is take whatever my exponent is, which is a 4, and I'm going to take the reciprocal of that. So that's 1/4. So I'm going to raise both sides of my equation to the 1/4 power. It's the same thing as taking the 4th root, which would be fine to do as well. So now I have a power to a power, so I powerply 4 times 1/4 is just 1. And now I have 9 to the 1/4. And of course, we want to remember your plus or minus. And you're going to put that into your calculator. So to do that, if you're unsure, you would do 9 raised to the, and you can use your alpha y equals button again, and do your 1/4 power. Write out your entire decimal. 1.732050808, and then round to the nearest hundredth. So 1 plus or minus 1.73. Okay. And then the last one is for example for scenario 3. So here we're given, so again, find x to the nearest hundredth again. So here we have 2 times log x equals 6.1. Just like with all the others, the first step is to isolate. So we want to get the log or ln by itself. So I want to get this log of x all by its lonesome. So to do that, I'm going to divide both sides by 2, because there's a 2 in the front that I need to get rid of. And then the log will be all by itself. So now I get log x equals 3.05. Once I have my log isolated, then I want to rewrite it in exponential form. So rewrite in exponential form. So remember, if you're given a log without a base, that tells us it has a base 10. If you forget that, go to your calculator, look on the log button, see above the log button here is 10 to the x. So now I rewrite that. So my base is 10. This is our exponent over here. So 10 to the 3.05 equals x. And that's what you need to memorize for your setup. Then you're going to type that into your calculator, 10 raised to the 3.05. Write out your entire decimal. And I'll give you guys a minute to pause and do that. I'm not going to write that one out, so I want you guys to write that out on your own, and then round to the nearest hundredth. So you should have gotten 1,122.02 for your final answer. Again, on your notes, you should have that entire decimal written out. All right, so now we're going to just kind of go through a few different problems and have you guys decide which scenario they're in and then actually solve them. So for the next problems that we're going to do, if this cooperates, find x to the nearest hundredth. All right. So the first one is 3 raised to the 2x plus 1 equals 8. So normally if you're in class here, then I would ask you to hold up with your fingers a 1, 2, or 3 for scenario 1, scenario 2, scenario 3. So first think about that to yourself. Maybe hold it up. All right, so you should have said, okay, well, there's a variable in the exponent, so this is going to be scenario 1. First step, isolate, isolate, isolate. There's nothing, I know the base is a 3 here, and there's nothing being added or subtracted to this base and its exponent, so we already have it isolated. Once we have it isolated, then we want to take the logs. So we're going to write log in front of each side of this equation. Everything else stays exactly the same. It's just I'm going to write a log in front of each side. Once I do that, now I can use my log properties, which I call the swoop property, and we're going to take our entire exponent and swoop it to the front. Now there is one really important thing to remember here. You swooped a 2x plus 1. So when you write that in front of your log, if you write it as I have it right here, you're only multiplying the 1 times log of 3, and the rest is being added to 2x. So this whole thing needs to go in parentheses. So those parentheses, very, very important. Okay, so 2x plus 1. And that's only if you only need the parentheses if it's a binomial like this one, 2x plus 1. If it was just 2x, you wouldn't have to write the parentheses. You could, but you don't have to. All right, so now I'm going to solve for x. So to do that, first I would divide both sides by log of 3. And now I'm going to just go to my calculator and type in log of 8 divided by log of 3. I'd like you guys to go ahead and type that in, please, into your calculators and get a decimal. So your decimal should be 1.892789261. And now it's just a matter of solving for x. So you're going to subtract your 1 and then divide by 2. And you could then write out our 2x equals 0.8927896261, and then divide by 2. And again, write out your entire decimal that you see. And you should have put this right into your calculator. And then round to the nearest hundredth, so 0.45. All right, let's try another one. So 2,000 equals 500 times 1.07 raised to the 3x. So take a moment here, see if you can figure out what scenario you would be in here, and then try to take this as far as you can. All right, so first of all, hopefully you realize you're in scenario 1 because the variable is in the exponent. We need to isolate, so I'm going to divide both sides by 500. Zeros cancel, 20 divided by 5 is 4. These cancel. So we need to isolate that base with its exponent. So it does have parentheses here, but the parentheses are around just the 1.07, which means that's your entire base. Now when the variable's in the exponent, you want to take logs. Logs get the variable out of the exponent. So you're going to write log in front of each side. And actually, I'll show you that other method that I mentioned before as well. So at this point, we're just rewriting log in front of each side. Once I do that, now I can use my log properties, which allow me to swoop, which is super fun. And now I have log 4 equals 3x. So here is not a binomial, so you don't have to have that in parentheses, but you're welcome to. 1.07. And now it's just a matter of solving for x. So we can divide both sides by log of 1.07. And you're going to put that right into your calculator. And then you would divide both sides by 3. So I'll give you guys pause a minute, pause and do that on your own. Write out your entire decimal and then round it to the nearest hundredth. Okay. Now let's talk quickly about, and that should have been 6.83. So doing the other method, you'd still need to isolate and do that first step. But once you get to this step right here, if you wanted to instead go straight to your logs, you could rewrite it as a logarithm. So your base is 1.07 and your exponent is 3x. So it would be 1.07 as your base raised to the 3x equals 4. And then you would just go to your calculator and type that in and then divide it by 3. So it is a bit faster, but you really have to understand how to set up your logs. For this one, going back to here for a minute, you could from here, once you isolated, which we already had, you could, just from the beginning actually, you would rewrite this as a log base 3. Our exponent is always alone, so the 2x plus 1 would go over here by itself. And then, so it'd be 3 raised to the 2x plus 1 equals 8. You would type this into your calculator, then subtract your 1, divide by 2. So that just gives you another way of doing it. It is a little bit shorter, so if you choose to do that, that is totally up to you. All right, let's try another one. Log base x of 16 equals negative 2 over 3. All right, first figure out which scenario you're in, 1, 2, or 3, and see how far you can get from there on your own. Pause the video now. All right, so hopefully you said you're in scenario 3, you're given a log or ln, so you're going to isolate it, which we don't have anything being added or multiplied to the log, so we're going to rewrite it in exponential form. So our base of our log is x raised to whatever's by itself, that's your exponent, so negative 2/3 equals 16. Now we're actually in a different scenario. Now our variable's in the base, so we're in scenario 2. And when we're in scenario 2, we want to isolate and then raise both sides to the reciprocal. So now we're going to take this and look at our exponent, which is negative 2 over 3. So we're going to raise both sides to the reciprocal. So it's not the negative reciprocal, it's just the reciprocal, because we want it, when we multiply those exponents, we want them to give us a positive 1. So we're going to raise it to the negative 3 over 2, since it's negative 2 over 3. So a negative times a negative is a positive. 2/3 times 3/2 is just 1. So that'll allow us to solve for x. So now I need to raise this side as well to the negative 3/2 power. So let's go through this to review our exponent rules. So I have a negative exponent, so that tells me it's going to go, I take the reciprocal of it. So since it's in the numerator, it's going to now go to the denominator. So it becomes 16 over positive 3 over 2 now. And now I have power over root, power over root. So I'm going to take the second power, which is the square root of 16, and raise it to the third power. So that gives me square root of 16 is 4, and 4 to the third power is 64. So I get x equals 1 over 64. All right, let's try another one. So this one is e to the x plus 1 equals 30. So for this one, Pause and see which scenario you are in. So here are your variables in the exponent, so you should be in scenario 1. For this one, again, it's already isolated. We don't have anything being added, subtracted, or multiplied to the e raised to the x plus 1, so our base is alone with its exponent. But instead of taking the logs here, because it's an e, I'm going to use ln. So here's your rule of when to use ln. When you see an e, use ln. CE. It's not cooperating again. When you see e, use ln as opposed to log. And when you see an ln, that tells us our base is e. It has a base of e. So here we have an e, so instead of taking the log of both sides, I'm going to take the ln of both sides. So the ln of e to the x plus 1 equals ln of 30. Now I can swoop to the front. Oh, it's a binomial, so make sure you use parentheses. So I have x plus 1 times the ln of e equals the ln of 30. Now, the reason we use ln's is because if you were to take the ln of e, so ln, and I'm going to use second divided by because it doesn't have an exponent, it gives me 1 because e to the first power gives me e. Number has a base of e, so you're always asking yourself, e, the base raised to what power gives me this number right here? So e raised to the first power is just 1, so that's just a 1. So now I just have x plus 1 equals ln of 30. So now go to your calculator, type in ln of 30, subtract your 1, write out your whole decimal, and then round it to the nearest hundredth. So you should have gotten approximately 2.40, and you do want to include that 0 as a placeholder right there for that one. So 2.40, and on your notes paper, I should see that entire decimal written out and rounded to the nearest hundredth. Right, the next one is 6x to the 5th minus 10 equals x to the 5th plus 8. All right, so here I notice I have some like terms. So before I even figure out what scenario in, I'm going to combine my like terms. So pause, go ahead and combine those. All right, so you should have said you've got 2x to the 5th, so I'm going to bring over the smaller one over to the left side, so that gives me 5x to the 5th. And I could add my 10 over to my 8, because those are also like terms, giving me 5x to the 5th equals 18. Now that looks a little bit more like what we've been seeing. So pause the video here, see if you can finish this one on your own. All right, so first we need to isolate. So the 5 is the exponent to the x, not the 5, because it's only touching directly the x. So I divide both sides by 5. Now that's not a nice number, so I'm just going to leave it as a fraction. So I have x to the 5th equals 18 over 5. Now I'm in scenario 2 where my variable is in the base. So when the variable's in the base, we isolate, which it already is, and then I'm going to raise both sides to the reciprocal. So my exponent is a 5, so that's 5 over 1, so the reciprocal is 1 over 5. It's like taking the 5th root of both sides. And we're really just going to type all of that into our calculator. So you're just going to go to your calculator and type in 18 over 5. And I didn't put parentheses, so I'm just going to hit enter and then raise to the 1 only 1/5 power. And then write out my entire decimal and round it to the nearest hundredth. So you should end up with 1.29 there. Again, on your papers, you should have the entire decimal written out and then also rounded to the nearest hundredth. And then the next one we're going to do, which is the last one we'll do for today, is ln of 3x equals 6. Pause the video here and solve this one on your own if you can. All right, so first of all, it's already isolated. There's nothing being added or subtracted. We're taking the ln of the entire 3x here. So now we're in scenario 3. So we want to rewrite this in exponential form. So we have an ln, which has a base of an e. So we rewrite it as e raised to the 6th power equals 3x. From here, you go to your calculator. You're just going to type in e to the 6th power. So I'm going to use this one, second ln, because it already has an exponent, but you could also do second divided by and then the caret key. So I get that long decimal, and then I'm going to write that out and then just divide both sides by 3. And actually, if you had wanted an exact value, you would leave it as e to the 6th over 3 for that one. But it says to round to the nearest hundredth, so then you're just going to type that right into your calculator. Again, write out the entire decimal, and then write out the decimal rounded to the nearest hundredth. Should be 134.48. So make sure, again, you have all of that written out on your papers when you write out the notes. And so these really important for these that you guys are looking at the scenarios, deciding what method to use, and then going through isolating first and then solving. If you have any questions at all, make sure you let me know. Pi out.